Welcome to Personal Web Tutor. Today's question is, we've got a tennis player and they hit a ball 2 meters above the ground. The ball leaves the racket with a speed of 20 meters per second at an angle of 5 degrees above the horizontal. The horizontal distance to the net is 7 meters and the net is 1 meter high. Does the ball clear the net? Alright, so let's draw our cool net here. Pictures worth 1,000 words. My net is all messed up. Alright, so we've got somebody over here. Stick figure. I'm good with stick figure. And in the racket, the ball comes and it gets hit. And it's got this velocity of 20 meters per second. And it's got this theta in here, which is equal to 5 degrees. And the distance between the ball and the net is 7 meters. And this height here is 1 meter. And the height above the ball is 2 meters. So what I want to do is I want to find the time that it takes the ball to get from here to the net. And I'm going to take that time and see where the height is with that time of the ball. The velocity here in the horizontal direction does not change. However, in the vertical direction, it does due to gravity, because you've got gravity going down. So we know that the velocity here in the x direction is going to be 20 meters per second cosine of 5 degrees. And that's going to be Vx. And then we know that Vy, just for later, is going to be 20 meters per second sine of 5 degrees. So we're going to go down here and we're going to use V equals x over t, and we're trying to find the time, so time is going to be equal to x over v. Our x here is 7 meters in the horizontal direction, so we're going to put that in as 7 meters, and our velocity in the x direction will be this right here. It's going to be 20 meters per second cosine of 5 degrees. So as we multiply this out, we see that these meters cancel, and we're going to be left with the time equal to 0.35 seconds. So now what we want to do is we want to take that 0.35 seconds and we want to find the velocity in the y direction, this initial velocity. Of course, we have gravity, we have this time, and we want to find out the y difference. So the formula that we're going to use is y final equal to y initial plus the initial velocity in the y direction times time plus 1/2 a in the y direction, which is g times t squared. Now we know that the initial y is 2. So let's see, we've got y final equals 2 meters plus 20 meters per second sine of 5 degrees times the time of 0.35 seconds plus 1/2 g is in the minus 9.8 meters per second squared times 0.35 seconds squared. So, here we go. We got y final is equal to 2 meters plus this whole thing here is equal to 0.61 meters. I forgot my seconds in there because that will cause the seconds there to cancel. And notice here second squared and second squared is canceled. And this whole part right here gives us a plus, and it's going to be negative because of that negative right there. This negative right there. So it's going to be a minus 0.60 meters. So, as you can see, YF is equal to 2 meters. We're going to plus 0.61, and then we're going to minus 0.6. So it's really plus a 0.01 meters, which really isn't that much. 2.01 meters. Now remember, the net was 1 meter. So when the net is 1 meter, that means it's going to go over by 1 meter. So the ball is going to go 2 meters, and then here's the net. And this right here is 1 meter. So the ball is going to go plenty of distance over the net. So if you have any questions about this problem here or any other problem, feel free to go to personalwebtutor.com. You can go here and ask a question, and it'll bring you to a form. Fill out the form, and you never know. Your question could be my next video. Thank you.